Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. We continue about the miscellaneous shaft components on keys and pins. Okay, this notes is taken from Shigley Mechanical Design book. Okay, from chapter 7 shaft and shaft component. Okay, and all the pictures is taken from Google Images. Okay, students, we are talking about keys and pins. Okay, you all are familiar with keys. You all know what is the images of a key. This is a key I'm holding in my hand. This is a key. Okay, this is also a key. Okay, this is my car key. Okay, meaning that you also have your hostel key, your room key, your house key, and you're also talking about pins. Okay, so if you this is all the shaft, this is the keys have this is a shaft. No, this is a shaft. Okay, in such a way, it is also a shaft. This is a shaft, and about the pin, this is the image of a pin. Okay, so we're talking about keys and pins. Okay, keys and pins are used on shaft on securing on to secure rotating elements such as gear, pulleys, and or other wheels. Keys are used to enable transmission of torque from the shaft to the shaft supported elements, and pins are used for either positioning for the transport of torque or thrust or both. Oh, so let's say this is a key. Okay, you put in your door. Okay, you put in your door and you twist with your hand and it's such a force that the door open. Okay, the door open. This is a function of key. Your hand is transmitting the torque, the force to the shaft, which is the key, and it make the mechanism open and you enter your house. Okay, okay. Figure 716. This is figure 716 shows a pin. Okay, this is a picture of a pin. Okay, picture here I get take from Google image from its picture of a pin, and figure 716 shows a variety of keys and pins. Pins are useful when the principal loading is shear and when the torsion and thrust are present. Taper pins are sized according to the diameter of the large end. Okay, so and then the small end diameter is like this. Okay, okay, this is the dimension for large and standard paper pins. Yeah, they have a standard. Okay, they have a standard. Uh, you can refer to this book or the catalog for the pin when you want to buy a pin for your purpose. Okay. Okay, this is the standard square and rectangular key application. The table 7.6 shows the each dimension for some standard square and rectangular key application, the shaft diameter, the key size, and everything. This is given in the textbook. Textbook also when you buy proper from the company, they give the catalog to you, and you can refer to the catalog. Okay. This is a dowel pin. Okay, less important application. Dowel pin can be used to drive your mechanism into the structure. Okay, to drive the mechanism into the shaft. Okay. Okay, failure of keys happen when the uh, the key is too long. The key is made of material is cannot support your load. Okay, let's say this door key. When you put in your door, it's supposed to open the door. Okay. However, maybe it jam. When the door is jammed, you push, you give the torsion, you give the shear, and it broke away. Okay. This part broke away inside the door. So what can you do? You change the whole door. You change the whole doorknob. Okay. Uh, So this is called the failure of key can be from direct shear, which is maybe because you push so hard to the door, okay, it make it shear, and or maybe from bearing stress, it it broke like a torsion, okay. In the end, you have to change your doorknob, okay. Okay, the shaft diameter determines standard sizes for width, key, and height and key depth. Okay, the designer chooses an appropriate key length to carry the torsional load. Failure of key can be direct shear or direct bearing. Okay, this is a picture I taken from Google Images. The picture of some keys that are fail. Okay, this photo shaft have been grossly overloaded by torsional stress. It broke away. Okay, and then this occasionally ductile shaft will fail in somehow brittle manner. Okay, so meaning that this is a key. Maybe if you it's easy to say that mm, given the proper size, okay, you calculate wrongly, using material that cannot support, maybe the key will fail. Okay, maybe the key will fail. Okay, you can imagine any key. The nearest to you is your house key, your hostel key, your car key, motorcycle key. It is been designed to support the load. Okay, if you design your own key, uh, you have to make sure all the size and width and everything is can carry the load. Okay, even if you buy the standard key from market, from the shop, you put in your doorknob, if you give excessive load to it may broke also. Okay, for maybe if you feel strong that day, you you try too hard uh, to open the door, your key may broke. Okay, maybe because of fatigue failure, you have opened the door thousand times throughout the door life. The key may fail because of fatigue cycle. Okay, how about the maximum length of key? Okay, so the length of key also have a length. Okay, the by the guidance is cannot should not exceed 1.5 times the shaft diameter to avoid excessive twisting. This is a picture such a key. Okay, it is an recreational key for aesthetic value. It is not a good design, but it's go for aesthetic value. People want to buy this type of key because it in previous generation from Victorian era, from previous your grandfather have antique value. Okay, so okay lah for antique value. It's not using for it is not using for everyday usage. Okay, for everyday usage, the the key is short. The key is short. Okay, so uh, make sure the shorter the better, but not that too short because you cannot put into the key slot. Okay, for antique purpose, buy this. Okay, you for your just for antique purpose, you want to do the collection and everything. This is for antique purpose. For everyday usage, the key must be short. Okay, material for key. The stock key typically made from low carbon rolled steel. Okay, in manufactured so that this dimension never exceed its nominal dimension. The nominal dimension is approximate or rough cut dimension where this material is generally called or sold in trade, which is differ from the actual dimension. Of course, we want to cut the key is must be shorter than its nominal dimension. Okay, uh, then uh, it made from low carbon raw steel because it's why you need to make the key from titanium. The meaning that such a waste of money. If you buy, maybe if that purpose have that purpose you make key from expensive material, but usually the key is made from uh, cheaper material like low carbon hot rolled steel. Okay. Okay, the Hiphop Key. This is the picture of a Hiphop Key. You see this portion. They have the portion like this. My hand is pulling like this. Okay, it's pulling like this. It have when you put inside the slot, it is in give an axial it will prevent relative axial motion, meaning that the key it does not moving in the axial direction. Okay, so it does not move in the axial direction, so your mechanism is safe lah. Kan? This is the Hiphop Key. This is called the Hiphop Key. Okay. And the last one is called the Woodruff Key. Okay, general for usage when wheel is to be positioned against a sharp shoulder, since the key slot cannot be machined into the shoulder stress concentration region, meaning that for that one type of key, you don't want that key to become accidentally rotation. You don't want it to accidentally rotate. Okay, you make a slot. You make a slot. Just make a slot and put this kind of Woodruff key inside the slot. Okay, when you attach that shaft with the Woodruff key inside the outer diameter, the bigger shaft, we will not rotate. Okay, will not rotate, meaning that it will not accidentally rotate. The structure will be safe, and you will also as a safety precaution to you also. Okay, okay, that's the end of the video today. We will continue with the next video on miscellaneous shaft component also, but we talk about retaining rings. Okay, thank you very much.